Hello everyone. Yeah, this is Abhishek KB. Welcome to my YouTube channel. Yes, last class we discussed about the introduction of determinants and we solved some basic 1 mark problems for your annual examination. Right? And in this session I am going to give a lecturing on the properties of determinants, which helps you to solve the determinant problem much easier. Before going to give a lecturing on properties of determinants, first I would like to solve some more problems on the determinants. Yes, for your annual examination, examiner like to ask these type of questions for 1 mark. Find the value of x. Find the value of x if determinant 2, 4, 5, 1, this is equal to 2x, 4, 6x. I already told you the difference between matrix and determinants, right? Matrix is a ordered rectangular array of numbers or function. Determinant is denoted by like this, that is, if matrix A is equal to A, B, C, D, then determinant of A is given by determinant of A, B, C, D. This is 2 cross 2 matrix. This is multiplication of diagonal matrix minus multiplication of anti-diagonal elements, right? So here they given 2 determinants and they give this equality sign. We need to find what? X. See, since it is 2 cross 2 matrix, determinant of this is given by, see, the product of diagonal elements, that is 2 into 1, 2, minus the product of anti-diagonal elements, minus 5 4s are 20. This is equal to same thing, 2x into x, 2x square, minus 6 4s are 24. Is it clear? This implies, see, this implies 2 minus 20 minus 18. This is equal to 2x square minus 24. This implies, take this minus 18 to RHS, then this equation becomes 2x square minus 24 plus 18. This is equal to 0. This implies 2x square minus 24 plus 18, this is equal to minus 6, this is equal to 0. Then this implies 2x square is equal to 6, this implies x square is equal to 6 by 2, this is 3. This implies x is equal to plus or minus root 3. All of you getting? See, this is how we are going to find the value of x for the equality of determinants. If the examiner give this type of question, you need to find the value of x. Is it clear? Then consider the next problem. Find the value of x. This is the second problem. Find the value of x for the determinant 2, 3, 4, 5. This is equal to x, 3, 2x, 5. X, 3, 2x, 5. See? 2 5s are 10 minus 4 3s are 12. This is equal to 5 into x, 5x minus 3 into 2x, 6x. This implies 10 minus 2, 12 minus 3. This is equal to 5x into 6x minus x minus will cancel from both sides. Then x is equal to 2. Very simple. See, examiner like to ask these type of questions for 1 mark. Please note down. Yes. Then the next type of question is question number 2. If A is equal to matrix contains the elements 1, 2, 4, 2, that is by 2 by 2, order 2 by 2, then show that determinant of 2A is equal to 4 into determinant of A. Determinant of 2A is equal to 4 into determinant of A. See, here the given matrix A is equal to 1, 2, 4, 2. Before going to determine this determinant or the determinant of 2A, we need to multiply this 2 with matrix A. This is matrix multiplication by a scalar. See, 2A is given by what? This 2 into what is A? 1, 2, 4, 2. This is given. And this scalar multiplied by all the elements of this matrix. Therefore, 2, 4, 8, 4. 2 1s are 2, 2 2s are 4, 2 4s are 8, 2 2s are 4. Then we need to find what? Determinant of 2A. 2A is the matrix of order 2 by 2, contains the element 2, 4, 8, 4. Determinant of A is given by determinant of 2, 4, 8, 4. We all know how to find the determinant for 2 cross 2 matrices. That is product of diagonal elements minus the product of anti-diagonal elements. 2 4s are 8 minus 8 4s are 32. This is equal to what? Minus 24. Minus 24. Call this equation 1. Call this determinant of 2A is equal to minus 24 as equation 1. Then we need to consider the RHS part, that is 4 into determinant of A. This implies 4 into determinant of what is A? The given matrix A has 1, 2, 4, 2. Then it becomes the determinant like this, that is 1, 2, 4, 2. It is the determinant is represented by like this. This implies 4 into, again, 2 by 2, product of diagonal elements minus product of anti-diagonal elements. This implies 4 into minus 6. This is equal to what? Minus 24. Call this equation 2. From 192, we have determinant of 2A is equal to 4 into determinant of A. This completes. Very simple, right? Please note. Now I am going to consider one more problem. If matrix A is equal to 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9, 5, 4 minus 9, find determinant of A. Find determinant of A. And this is first one. And second one, B. If B is equal to 3 minus 1 minus 2, 0, 0 minus 1, 3 minus 5, 0. Find determinant of B. First, I am going with the second problem. See, here they given the matrix. The determinant of B is given by determinant of 3 minus 1 minus 2, 0, 0 minus 1, 3 minus 5, 0. This is the matrix of order 3 by 3. We already know how to find the determinant for this kind of matrices. We discussed about the procedure to find the determinant for 3 cross 3. Yes? I already told you, to find for easier calculation, we need to consider row or a column which contains the maximum number of zeros for easier calculation. Right? We have totally 6 ways to find the determinant. Either expanding R1 or R2 or R3, either expanding C1 or C2 or C3. That is row 1, row 2, row 3, column 1, column 2, column 3. See here we should observe that R2 has, that is row 2 has 2 zeros. So we should go through the expansion along R2. Is it clear? So expanding, answer for this question, expanding along R2. Then see determinant of B is equal to, see I already told you, plus minus plus minus plus minus. This is A11 element, I plus j, 1 plus 1 2, minus 1 to the power of 2 1. That is, this is plus minus plus minus plus minus plus minus plus corresponding, right? So minus 0 into anything 0, no need to calculate that. Plus 0 into anything 0 only, no need to calculate this thing also. Then minus 1 minus plus minus minus 1 into, see this is A23 element, this is the element of A23, that is second row third column. We need to cancel second row third column. We have what we have, we remaining, it reduces to 2 by 2, 3 minus 1, 3 minus 1. Is it clear? This is equal to what? Minus 1 into, it is of order 2 by 2, product of diagonal element minus product of anti-diagonal element, minus 50, minus into minus what? See, minus of minus 3 into 1, minus 3. This is equal to what? Minus 1, minus 50, minus into minus, plus 3. This is equal to what? Minus 1, minus 15 plus 3, minus 12. This is equal to plus 12. Is it clear? So, and here, determinant of A is equal to determinant of 1, 1 minus 2, 2, 1 minus 3, 4 minus 4 minus. No row or a column contain at least 1 0. So, go through any rows or column. Expanding along any row or column, you will get the same answer. I left this problem to you only. I hope you are all getting how to expand for the given determinant. Okay, this is for 1 marks. These are all for 1 marks. Last class problems and this class problems. All of you clear about this? Yes. Thank you. Yes. Now I move on to the properties of determinants. Now I move on to properties of determinants. These properties helps us to solve the determinant problem much easier. Okay, let us move on to the first property of determinant. The value of the determinant, the value of the determinant, the value of the determinant is unchanged, if its rows and columns, if its rows and columns are interchanged, if its rows and columns are interchanged. The value of the given determinant remains constant, that is unchanged, if its rows and columns are interchanged. For example, consider the determinant of 2 minus 3 5 6 0 4 1 5 minus 4 1 5 minus 4. What is the value of the determinant? We already know how to expand, how to proceed for 3 cross 3 matrices, right? See, this is the order of 3 by 3. And I already told you, you should expand a row or a column which contains the maximum number of rows, a maximum number of zeros, right? Here, R2 has 1 0 and C2 has 1 0. Better to go through R2 instead of C2. For C2 also giving the same answer. See, expand along R2. Expand along R2. Then value of the determinant is given by, see, A11, A12, A13, A21 suffix is 2 plus 1 3 odd, so we need to multiply by minus 1 into 6. And this is A21 element, sorry, yes, A21 element, we need to, that is second row first column, we need to delete second row first column. We are remaining with minus 3, 5, 5, minus 4. Here it is minus, the next element should be plus 0. 0 into anything, that is 0 means this column, this row. We are remaining with 2, this column, this row. 2, 5, 1, minus 4. Then minus, next element is minus. Minus 4 into this column, this row get cancelled. We are remaining with 2, minus 3. 1, 5, 2 minus 3, 1, 5, see, minus 6 into minus plus, 3 4s are 12, minus 5 5s are 25, plus 0 into anything, 0, no need to calculate this, minus 4 into 5 2s are 10, plus minus, plus into minus, minus into minus, plus 3 into 1, 3. Is it clear? This implies minus 6 into 12 minus 25. This is minus 13. Minus 4 into 10 plus 3, 13. This implies minus into minus plus. 6 3s are 18, carry 1, 3, 6 1s are 6, 6 plus 1, 7. Minus 4 3s are 12, carry 1, 4 1s are 4 plus 1, 5. This implies 8 minus 2, 6, 7 minus 5, 2. Therefore, the value of the determinant of this determinant is 26. What the property says? The value of the determinant is unchanged if its rows and columns are interchanged. Value of the determinant is 26. Now, I am going to interchange rows and columns. What is the meaning of changing rows and columns? It is the definition of transpose of a matrix, right? So, if I am going to change row to column and column to rows, that is 2 minus 3 5 is in first row, I will change it into first column, 2 minus 3 5. Similarly, 6 0 4, R2 changes to C2 and R3 changes to C3. Now let us check what happens. The property says if its rows and columns are interchanged, the value of the determinant is unchanged, right? So if I am going to consider, again I will go through R2 only because it has 1 0, but R1 has no zeros, R3 has no zeros. If you go through C2, no problem. I am going to expand along R2. Expand along R2. Then see, plus minus plus minus into minus 3. This is plus 3 into deleting this column, deleting this row. 6 4s are minus 24. This row, this column. Plus into minus again minus 4 1s are 4. Then I already told you. Plus 0 into anything 0, so no need to calculate this one. Then minus 5 into this column, this row. 2 4s are 8 minus this column, this row. 2 4s are 8 minus 5 6 are 30. Is it clear? Then this is equal to 3 into minus 28 minus 5 into minus 22. Is it clear? Then this implies 3 8s are 24 carried through 3 2s are 6 plus 2 minus 84. Minus into minus plus 22 5s are 25s are 100, 2 5s are 10. This is 110. Again 110 minus 84 is 26. See, value of this determinant also 26. See, if that's the property says. The value of the determinant is unchanged if its rows and columns are interchanged. This is the first property you should learn. I hope you are all getting this. Is it clear? Yes. Please note it down. Thank you. Yes. Now I move on to the second property of determinant. The first property says the value of the determinant is unchanged if its rows and columns are interchanged. The second property says if any two rows or columns, any two rows or any two columns are of a determinant are interchanged, then the sign changes. See, first property says the value of the determinant is unchanged if its rows and columns, all its rows and columns are interchanged, then the value of the determinant is unchanged. Here, the second property says if any two rows or two columns are interchanged, then the value of the determinant changes its sign. For example, if I consider the same example, that is 2 minus 3, 5, delta is equal to 2 minus 3, 5, 6, 0, 4, 6, 0, 4, 1, 5, minus 4. 1, 5, minus 4. We already did this. What is the value of the determinant? This is equal to plus 26. Yes, plus 26. Then the property says if any two rows or columns are interchanged. If I am going to change R1 and R2, that is replace R1 by R2 and R2 by R1, that is 6, 0, 4, R2 changes to R1 and R1 changes to R2. 2 minus 3, 5, 1, 5, minus 4. The property says if any two rows or columns, here we changed what? Rows, two rows, then the value of the determinant changes its sign. It is plus 26. Now let us check whether it gives minus 26 or not. See, this is equal to, now I am going to expand. Now I am going to expand along R1. Since this determinant, that is R1 has 1 zeros. Therefore, it is easy to calculate along R1. See, plus 6 into deleting the first row and first column. We are remaining with this determinant minus 3, 5 and minus 4. Minus into minus plus 12 minus 5 5 are 25. Then minus 0. 0 into anything 0. So no need to calculate that. Then consider the next one. That is plus 4 into deleting the corresponding column and corresponding row. We are remaining with 2 minus 3, 1, 5. 2 5s are 10. Minus 3 into 1 minus 3. Here minus into minus 3. That is plus 3. This is equal to what? See, 6 into minus 13 plus 4 into plus 13. 6 into minus 13 plus 4 into 13. This is equal to 6 3s are 18. Carry 1. 6 1 are 6 plus 1 17. Minus 78 plus 33s are 52. Minus 78 plus 52 is what? Minus 26. This is the beauty of mathematics. That is, the second property says if any two rows and columns are interchanged, then the determinant changes its sign. See, here they given plus 26. Here I am not going to change any row and column. If I am going to change this R1 to R2, R2 to R1, if you are going to change C1 to C2, C2 to C1, again you will get the same answer. Is it clear? So this is about the second property. Please note down. Yes, then I move on to the third property of determinant. The property 3 says if any two rows or columns, any two columns of a determinant, any two rows or columns of a determinants are identical. This means the corresponding elements are same. Any two rows or columns of a determinant, if those two rows or columns corresponding elements are simply call it as identical. Then value of the determinant, value of that determinant, value of the determinant is 0. Value of the determinant is 0. That means if the examiner give 5 or evaluate 3, 2, 5, 2, 2, 1, 3, 2, 5. No need to expand along R1 or R2 or R3 or C1 or C2 or C3. Simply you write it as this equal to 0. Because, sir, why? See, the third property says if any two rows and columns are identical, then the value of the determinant is 0. For your CET examination, examiner like to ask this type of question, evaluate within a second. You will say because R1 is equal to R3. See, R1 is equal to R3. See, sir, we need proof. Yes. For proof, go through expand along R1. See, plus 3 into, deleting this column, this row, 2 5s are 10, minus 2 into this column, this row, 2 5s are 10, minus 3 1s are 3, plus 5 into this column, this row, 2 2s are 4, minus 3 2s are 6. This implies 3 into 10 minus 2, 8, minus 2 into 10 minus 3, 7, plus 5 into 4 minus 6, minus 2. This is equal to 8 3s are 24, minus 7 2s are 14, minus 5 2s are 10. See, 24 minus 14 minus 10, minus 24. What is 24 minus 24? 0. No need to calculate all these things. If you have any two rows and columns are in the chain, directly you can write 0. That's why I told you properties of determinants gives the easier calculation to for the expansion of the determinant. Is it clear? This one. Yes, let us move on to the last two properties of determinant. Property 4 says if each element of a row or a column of a determinant is multiplied by a constant, say k, then the value gets multiplied by k. For example, see, if you have the delta, that is determinant, is equal to 8 4 1 2, 8 4 1 2, and see, this is equal to, if I am going to take 2 common in R1, take 2 common in R1, then see, if I am going to take 2 common in R1, then 2 4s are 8, 2 2s are 4, R2 remains same. This is not matrix, this is determinant. Keep remembering. See, if I have A is equal to 1, 2, 3, 4, then 2A is equal to 2, 4, 6, 8. This is matrix multiplication based here. But if I have 2 into determinant of A, 2 into determinant of 1, 2, 3, 4, we have not any rights to multiply this constant throughout the element, because this is a determinant. See, please remember this point. If you are going to multiply this 2, 4, 6, 8, then you are getting 16 minus 24. This is equal to minus 8. But what is the value? 2 into 4 1s are 4, minus 3 2s are 6, 2 into minus 2. The value of the determinant is minus 4, not minus 8. Is it clear? I hope you are all getting this. Be careful, okay? Then here comment in R1. Here the property says if each element of a row or a column of a row, it may be single row, it should be single row or a column. See here, If I have right, see, take 2 common in C2, then C1 remains same, then 2 into 2 2s are 2s. Again, see, 2 into 8 ones are 8 minus 2 ones are 2. This is equal to 2 into 6. This is equal to 12. Is it clear? Is it clear? See, this is how we are going to find the value of the determinant. And if you have A is equal to, determinant of A is equal to A, B, C, D, then K into A is equal to R. And A is equal to R. A is equal to K, A, K, B, C, D. Then you have rights to take K common in R, and then A, B, C, D. Is it clear? See, K into this. That's why the property says determinant is multiplied by a constant K, then its value gets multiplied by K. Value of the determinant is equal to this multiplied by K. Is it clear? Yes. Now I move on to the last property, that is, if sum or all elements of a row or a column of a determinant are expressed as sum of, see, sum. If sum or all elements of a row or a column of a determinant are expressed as the sum of 2 or more terms, then determinant can be expressed as sum of 2 determinants. See, for example, if the examiner gives this determinant contains the elements of order 3 by 3, a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3, b1, b2, b3, c1, c2, c3. This determinant can be written as sum of 2 determinants. How? See here, R1 as expressed as sum of 2 elements. So sum of 2 elements can be expressed as sum of 2 determinants. See, A1, A2, A3, B1, B2, B3, C1, C2, C3 plus. Again, we are remaining with what? Another elements. Lambda 1, lambda 2, lambda 3. Lambda 1, lambda 2, lambda 3. Again, R2 and R3 remain same. B1, B2, B3, C1, C2, C3. And you should remember, value of this determinant is equal to value of these two determinants. I left that work to you only. Yes, I hope you are all getting the properties of determinants. Yes, let us move on to the problems on the properties of determinants. Using the properties of determinants, we are going to solve some problems on the given determinant. Yes, and here you should observe, this is the question for 4 marks for your annual examination in part E. Part E is for 6 plus 4, right? So this is the first possible question. 49A is this type. Okay, and here is the procedure to solve this kind of property problems using the properties of determinant. First, you should observe any common rows or columns. You should observe if we have any common rows or columns, because third property says if any two rows and columns are identical, then the value of the determinant is equal to 0. See, if I am going to consider this problem, 102, 18, 36 is in R1. If I am going to take 6 as common, see, 6 into 17, 17 6 are 102, then 6 into 3, 18, 6 into 6, 36, then 1, 3, 4, it remains 17, 3, 6. According to the fourth property, you can take 6 as common. Value of the determinant is multiplied by a constant is same. See, what is the constant here? 6. Take 6 common in R1, then we are remaining with 17, 3, 6, 1, 3, 4, 17, 3, 6. See, 6 into, if any two rows and columns are intersected, then the value of the determinant is 0. See, here R1 is equal to R3, therefore we can easily write this determinant is equal to 0. See, this is the use of the properties. Okay, see, why it is 0? Because R1 is equal to R3. 6 into 0, 0. See, this is how we are going to solve the given determinant using the properties. Okay, let us move on to the next one. This A, B, C. The fifth property says if any row or a column expressed as two elements, then that determinant can be written as sum of two determinants. See, R2 expressed as sum of two elements, A plus 2x, A plus 2y, B plus 2y, C plus 2z. This determinant can be written as A, B, C, x, y, z plus sum of two determinants. See, A, B, C. Here 2x, 2y, 2z. Here x, y, z. Again, for this determinant R1 is equal to R2. We can simply write it as 0 plus. Again, we have, see, 2x, 2y, 2z, x, y, z. These two rows are not identical, but it can be identical by taking 2 as common in R2. See, A, B, C, x, y, z, x, y, z. This can be written by the property 4. Again, 0, 0 plus 2 into. Again, R2 is equal to, for this determinant, R2 is equal to R3. We can write this 2 into 0. Again, this value is equal to 0. Please note down. Yes, let us move on to the next type of problems. Examiner like to ask these type of problems for 4 marks for your annual examination, and this one is very important. Repeated question. See, here delta is equal to, prove that this determinant x plus y plus z, z plus x, z, x, y, 1, 1, 1 is equal to 0. I told you, you should use the properties. See, if any row or a column expressed as sum of two or more elements, then that determinant can be written as sum of two determinant, right? Then after that, you should observe whether we getting any simplification for that for using that property. See, if you are going to express this sum of two elements as sum of two determinants, then you are getting what? X, y, z, z, x, y, 1, 1, 1 plus y, z, x, z, x, y, 1, 1, 1. Is there, this is by what? By property 3. Sorry, property 5. By property 5, we can expand sum of two elements as sum of two determinant. Is there any use? See, x, y, z, z, x, y, 1, 1, 1. It can be expand along R1 or R2 or R3, C1 or C2 or C3. For this also, R1, R2, R3, C1, C2, C3. From this, either taking these two, instead of taking these two determinants, it is enough to take this also, this one only. See, by R1, R2, R3 or C1 or C2 or C3. See, then this is not necessary, right? So for this we need to do something, right? So what can we do? See, R1 changes to R1 plus R2 plus R3. First observation is you should observe whether you getting any two rows or columns are identical, or if it is possible to make any two rows or columns are identical, then you can do by same as the previous problem. But this has no use to expand to express the sum of two determinants. So I'll go through this operation, that is R1 changes to R1 plus R2 plus R3. That is, you should change row 1 by which operation? R1 plus R2 plus R3. See, delta is equal to determinant of, and you should keep it in your mind, you are going to change only R1, not R2, not R3. So write R2 and R3 whatever you have in the above determinant, and you are going to change what? R1. Which operation? What is the operation? R1 plus R2 plus R3. What is R1? See, x plus y, first element, x plus y plus corresponding element of R2, R1, R2, Z, or it is enough to take R1 plus R2. I tell you why. See, then R1 plus R2 for second element of R1, that is y plus z plus what is R2? X. X plus y plus z, y is plus z plus x, both are same. This can be written as x plus y plus z. And same for third element, z plus x plus y. This is also equal to x plus y plus z. See, we are getting x plus y plus z, x plus y plus z, x plus y plus z. If any row or a column has same element, take out that common, that is multiplied by the constant or variable. See, what is the common? R1 is common. Take x plus y plus z common in R1. What is remaining? X plus y plus z divided by x plus y plus z 1. Similarly 1. Then z x y 1 1 1. See, I already told you. If you don't get in any two rows or columns are identical, try to make it any two rows and columns are identical. What is the operation for that? R1 changes to R1 plus R2. X plus y plus z, x plus y plus z, x plus y plus z. Take out that common. You are getting 1 1 1 z x y 1 1 1. Here R1 is equal to R3. You can easily write value of the determinant is equal to 0. 0 into x plus y plus z is equal to what? 0. See, this is the technique to solve these kind of problems. This is for 4 marks. Yes. Let us move on to the important problem. See, here you have no rights to write this determinant as 2 determinant because b plus c a, this second element is not expressed as sum of 2 elements. If any row or a column expressed as sum of 2 elements, then that determinant can be written as sum of 2 determinant. See, b plus c, b, c, only this element in C1 and only this element in R1 expressed as sum of 2 elements. Any row or a column, throughout that row or a column are expressed as sum of 2 elements, sum of 2 or more elements, then only you have rights to write that determinant as sum of 2 determinant. In this case, you have no rights. Is it clear? Then what can we do? And we need to prove that what? This is equal to 4ABC. Consider the LHS part. See, if I am going to change R1 to R1 plus R2 plus R3, B plus B, 2B plus 2C. Here I get 2A plus 2C. What is the use? There is no use, right? Then addition is also not possible. First observation is whether 2 rows or columns are identical, then we can write is equal to 0. If it is not, then try to make that by some operation. By the operation also by addition or subtraction, we are not getting the same rows. Any 2 rows or columns are identical. Then the next procedure is what can we do? See, R1 changes to R1. Then the last step is you need to try to make the determinant any row or column as maximum number of zeros. See, R1 changes to R1 minus R2 minus R3. R1 changes to R1 minus R2 minus R3. What happens? See, I already told you, for changing R1, R2 and R3 remains same. R1 changes to what? B plus C, R1 minus corresponding element of R2 minus B minus corresponding element of R3. See, B get cancelled, C get cancelled. Your remaining is 0. First observation is to observe whether any 2 rows or columns are identical, or if it is not identical, try to make those 2 rows and columns are identical by some operation. If it is not possible, then go through more operations. Try to make any row or a column as maximum number of zeros. See here, if I consider A R1 minus R2, C minus A minus C. See, A get cancelled. A minus C minus A minus C. Again, we are getting what? 0. Then A minus B, A minus B minus A minus B minus A minus B minus A minus B. See, A get cancelled. We are remaining with 2B. Is it clear? Then see, we are getting R1 as 2 zeros. Now expand along R1. See, instead of going through R1 in starting, try to make any row or a column as maximum number of zeros. Then expand along that corresponding row. Then expand along R1. Since it has 2 zeros, then we move on to this. See, B plus C minus B minus C. Check it out whether this problem has what? B plus C A B, C plus A B, C A plus B, C A plus B. See, here C is not possible to get cancelled, right? Here A minus C minus A minus C. A get cancelled, remaining with what? Minus 2C. Minus 2C. Be careful. Okay? Then it gives minus 2B. Now it has 1 zeros. Now go through expanding along R1. Then 0 into anything 0. Plus minus. Minus into minus plus 2C. This column, this row get cancelled. B into 2C into B into A plus B minus B into C BC. Then minus plus into minus minus 2B plus minus plus into minus 2B. Deleting this column, this row. B into C BC minus C into C plus A. C into C plus A. C into C plus A. This is equal to 2C into AB plus B square minus BC minus 2B into BC minus C square minus into minus plus AC. This implies 2C into A, sorry, it is not possible to get cancelled. 2ABC plus 2B square C minus 2BC square minus 2B square C minus into minus plus 2BC square minus plus into minus plus C minus into minus plus into minus it is minus into minus plus 2ABC. Then 2B square C plus 2B square C minus 2B square C get cancelled. Minus 2bc square plus 2bc square get cancelled. 2abc plus 2abc is equal to what? 4abc. This is equal to RHS. This is a very important problem for your annual examination, and this completes some problems on the determinants. Try to solve more problems which I gave in my description part. Yes, I will meet you in the next class with the next subtopic of this chapter, determinant, that is minors cofactors. Thank you everyone. Take care. Bye bye.